First, I imported two libraries, Python import tkinter as tk import. Random tkinter is used to create the game window and graphics, while random is used to generate different pipe positions so that the game is not always the same. At the beginning of the code, I also defined some settings such as the screen width and height, bird size, gravity, flap strength, pipe width, pipe gap, and pipe speed. For example, Python width equals 400, height equals 600. This creates a game screen that is 400 pixels wide and 600 pixels high. The main part of my program is the Flappy Bird class. Inside the class, I have different functions that control different parts of the game. The __init___ function is the first function that runs when the game starts. Here I create the game window using tkinter's canvas. I also set the keyboard controls. The spacebar and up arrow are used to make the bird flap, and R is used to restart the game. The reset_stateos function sets the starting conditions of the game. For example, it sets the bird's position, velocity, score, and game over status. It also creates the bird using Python self.canvas.create_oval. So instead of using an image, I created the bird as a simple yellow oval. The score is displayed at the top of the screen, and an information message tells the player to press space to start. Next comes the pipe system. I created a function called Python spawn_pipe. This function creates the top and bottom pipes. The important part is that the gap between the pipes is randomly positioned using Python random.randint. This means the gap changes every time a new pipe is created. The player has to control the bird and move through this gap without touching the pipes. The movePipes function moves the pipes from right to left. Every frame, the pipe's x-coordinate is reduced by the pipe speed. When the bird successfully passes a pipe, the score increases by 1. The program also removes pipes after they leave the screen and creates new pipes on the right side. This makes the game continue instead of having only 2 pipes. One of the most important parts of this project is collision detection. I created a function called Python check_collisions. This function checks whether the bird touches the ceiling, ground, or pipes. For example, if the bird's bottom reaches the ground, the function returns Python true. The same thing happens if the bird touches a pipe. When a collision happens, the game calls the end_gameParents function. The bird has gravity and velocity. Inside the update parents function, gravity is continuously added to the bird's velocity. Python self.bird_velocity plus equals gravity. Then the bird's position is changed using its velocity. When I press space, the flap function gives the bird a negative velocity. Python self.bird_velocity equals flap_strength. This makes the bird move upward. After that, gravity pulls it down again. This creates the basic flying effect of the game. 8. Game loop. The update function acts as the main game loop. It continuously updates the bird's position, moves the pipes, checks collisions, and updates the screen. I used Python self.root, after open parenthesis, frame_delay, self.update, close parenthesis. This tells tkinter to run the update function again after a short amount of time. Because this happens continuously, the game appears to be when the bird hits a pipe, the ground, or the ceiling, the end_game function is called. The game stops updating and displays game over, the score, and an instruction to press R to restart. When the player presses R, the restart function calls reset state and starts the game again. In conclusion, this project helped me understand how Python can be used to create a simple graphical game. Through this project, I learned about tkinter, classes, functions, variables, loops, keyboard events, random numbers, collision detection, game physics, and game loops. The most interesting part for me was implementing gravity, pipe movement, collision detection, and the scoring system.